Today we are going to be talking about experimental design. Got a couple state standards listed here. The second one is different than the previous lesson, distinguish between a statistic and a parameter, evaluate reports based on data, and recognize when poor conclusions are drawn from well-collected data. The first one is the same as what we've been looking at in the past two lessons. Success criteria, you need to be able to assess the validity of an experiment's results. You need to be able to design an experiment or observational study, and you need to be able to analyze experimental designs. There is a few new vocab. Make sure that you get these in your notes and you go over them a few times. Hopefully they will not be too difficult. In a controlled experiment, groups are studied under the same conditions with the exception of one or more variables of interest. A treatment group is a group that is subjected to a treatment, and that's called the treatment group. A control group is a group that is not subjected to the treatment. A placebo, subjects in a control group are sometimes given a placebo, which is a harmless fake treatment that is similar to the actual treatment. And then randomization, randomly assign subjects to different treatment groups. And in a randomized comparative experiment, subjects are randomly assigned to the control group or the treatment group. So again, make sure those are in your notes. Make sure you go over them a few times and you kind of understand the wording. Hopefully they're not too difficult. Example 1, evaluating published reports. Determine whether each study is a randomized comparative experiment. If it is, describe the treatment group, and the control group. If it is not, explain why not and discuss whether the conclusions drawn from the study are valid. All right, there's two parts here, A and B, so let's look at A part first. This says under Health Watch, it says vitamin C lowers cholesterol. At a health clinic, patients were given the choice of whether to take a dietary supplement of 500 milligrams of vitamin C each day. 50 patients who took the supplement were monitored for 1 year, as were 50 patients who did not take the supplement. At the end of 1 year, patients who took the supplement had a 15% lower cholesterol level than patients in the other group. All right, so we're supposed to determine what kind of study this is. So is this a randomized comparative experiment? All right, so think about what it's asking. So does taking vitamin C every day, 500 milligrams, lower your cholesterol? Well, not necessarily. They observed these patients for a whole entire year. So if you think about a whole entire year, maybe they eat healthier, maybe they exercise, maybe they're doing other things in their daily habits that would affect their cholesterol to be lower. So it's not necessarily just the vitamin C would cause it to be lower. So when it says at the end of 1 year, patients who took supplements had 15% lower cholesterol level than patients in the other group. So that's what they observed, but they can't necessarily conclude that it's all because they took vitamin C. So in conclusion for A part, the study does not represent a randomized comparative experiment because the individuals are not randomly assigned to a control group or a treatment group. And the conclusion that vitamin C lowers cholesterol, that may or may not be valid based on the things that I mentioned earlier. All right, so remember we're trying to determine whether each study is a randomized comparative experiment. If it is, describe the treatment group, and the control group. If it's not, explain why and discuss whether the conclusions drawn from the study are valid. So let's look at B part, restaurant ordering. Now order even faster. To test its new touchscreen kiosk, the restaurant randomly selected and divided 186 customers into two groups. One group used the new touchscreen kiosk and the other group ordered at the counter. Users of the new touchscreen kiosk receive their food orders 25% faster. All right, so this one would be a randomized comparative experiment. Remember, a randomized comparative experiment is when subjects are randomly assigned to a control group or a treatment group. So if we look at B part, and we're talking about new touchscreen kiosks at a restaurant, it says that they randomly selected and divided 186 customers. So that means the treatment is the use of the new touchscreen kiosks. So the treatment group would be the individuals or the people who use the new touchscreen kiosks. The control group would be the individuals who order at the counter. Example 2, designing an experiment or observational study. Determine whether the following research topic is best investigated through an experiment or an observational study. Then describe the design of the experiment or observational study. All right, so the question is, does practicing yoga result in fewer falls for older people? All right, so when you think about that, when you think about yoga and older people, you have to consider the fact that some older people may be unhealthy and not be able to do yoga. So that would lead me to think that instead of doing an experiment, you probably should do an observational study. So if you do an observational study, you could randomly choose a group of older people who already practice yoga, and then you could just watch them and observe them to see if they had very many falls. And then you could randomly choose another group of older people who do not practice yoga and see if, kind of observe and take note of how many falls they have as well. So you could compare the two groups after a certain amount of time, but I do think the observational study in this case would be better than an experiment because, again, you don't want to randomly choose people and put them in different groups if they're not physically able to do yoga in the first place. So that means that you're able to divide, you would be able to identify a correlation between yoga maybe and people having less falls, but you can't really determine if it causes it or not. So the cause and effect, that part of it you would not be able to determine. So if you look up here, it says comparative studies and causality. A well-designed randomly comparative experiment by eliminating sources of variation other than the controlled variable can make it possible to draw valid cause and effect conclusions. An observational study can identify a correlation between variables, but not causality. Variables other than what is being measured may affect the results. So again, kind of what I said down here, we're doing an observational study. We're just going to observe older people in a group that do yoga. We're going to observe a different group not doing yoga, and then we could see maybe a correlation, but not that causality. And I'm going to let you guys answer this in your own words. I'm going to move on to example 3. Example 3, analyzing experimental design. A pharmaceutical company wants to test the effectiveness of a new chewing gum designed to help people lose weight. Identify a potential problem, if any, with each experimental design. Then describe how you can improve it. A part says the company randomly selects 10 people who are overweight. 5 subjects are randomly assigned to receive the new chewing gum, and the other 5 receive a placebo. After 3 months, each subject is evaluated, and it is determined that the 5 subjects who have been using the new chewing gum have lost weight. All right, so the first thing that comes to mind when I see this is 10 people is not very many, and then you're given 5 the new chewing gum, and you're giving the other 5 a placebo. So I would say that the sample size is not large enough to actually get any kind of valid results. So to improve this, what you could do is just make the sample size larger. B part says the company randomly selects 10,000 people who are overweight. The subjects are divided into two groups according to where they live. Subjects who live in a city receive the new chewing gum, and subjects who live in rural areas receive the placebo. After 3 months, a significantly large number of the subjects who live in a city have lost weight. All right, so again, we're looking for potential problems in the experimental design. So for this one, 10,000 people, that's a good number. So we don't have to worry about the number that they're randomly selecting. What we do have to look at is that they're divided into two groups according to where they live. Some live in a city and some live in rural areas. So the problem with that is all of them in the city are given the new chewing gum, and all of them in the rural areas are given the placebo, which would cause a design flaw because they may have different lifestyles. Like people in the city may have to walk a lot more than the people in rural areas. Rural areas where you live so far away from things, you usually hop in a car to drive to wherever. Whereas if you live in the city, you often walk a lot more places than you do in rural areas. So in order to fix this, you still could have different groups both in the city and rural areas, but you would need to divide those evenly somehow into where half of the people in the city and rural area get the treatment and the other half get the control group, which would be the placebo. And the first half would get the chewing gum, the second half get the placebo, but that would make it a little bit more fair. C part says the company randomly selects 10,000 people who are overweight. The subjects are divided into groups according to age. Within each age group, subjects are randomly assigned to receive the new chewing gum or the placebo. After 3 months, a significantly large number of the subjects who receive the new chewing gum have lost weight. All right, so they do separate them into different age groups, but within those age groups, some of each get both the new chewing gum and the placebo. So because they're divided into groups, but then they're randomly assigned the new chewing gum or age groups, and it looks like there's really no experimental design flaw here. So I would say there's no potential problems for this one. This one, C part, would actually be a pretty good experiment to find out if the new chewing gum actually does what they say and helps people lose weight. So out of the 3 scenarios here, if the pharmaceutical company wants to test the effectiveness of the new chewing gum design, I would suggest going with C. C has the least likely chance of having a potential problem with the effectiveness of the study. All right, that's it for this lesson. If you have any questions, please let me know.